Okay, so what we're going to do today is Chapter 9, problem number 11. So refer to this scenario in problem 8 using the file cell phone. An Excel miner's partition with oversampling procedure. Partition the data with all the variables so there is 50% successes, which is Turner's, and the training set, and 40% of the validation data are taken away as the test set. Use 1, 2, 3, 4, 5 as the seed in the randomized sampling. Construct a logistic regression model using churn as the output variable and all the other variables as input variables. Then perform variable selection with the best subsets procedure with the number of best subsets equal to 2. And then Y is partitioning with oversampling advised in this case. And the key item, really what I'm going to key in on, is just part B here, because that's a lot of people are having trouble with that. And that's from the generated set of logistic regression models. Use the Mallow's CP statistic to identify a pair of candidate models, then evaluate these candidate models based on their classification error on the validation set and decile wise lift on the validation set, and then recommend the final model and express the model as a mathematical equation relating the output variable to the input variables. And does the relationship suggest the model makes sense? All right, so really a key is trying to figure out what model to use. All right, so first we're supposed to do the partition with oversampling. And so we go to partition oversampling. Now, of course, now as soon as we choose the data, it's going to switch us to the data set. So now I have to read the book, make sure. So churn through roaming minutes, we're going to put over here. We'll put that churn as our output variable. We want that to be 40. The seed is 1, 2, 3, 4, 5. And I believe that is all we need to worry about for this one. So that gives us our partition data. All right, and as you can see, I'm using Excel tonight because for some reason my online version is not working, so I went to switch and did the Excel version. All right, so now what we need to do is logistic classification. So we're going to do logistic regression on the data partition. And here that's going to be our output variable. The rest of them are going to be our selected variables. Next, now we want the variable selection, and we're going to perform it, and we want the best subsets, and we want 2 for the number of best subsets. Now it doesn't say anything to do about the maximum, so we're not going to worry about that. So we're just going to leave it as 10. So then we say OK, and go next. Now I want detailed reports on everything, so I'm going to click on all of those, and then I'm going to say finish. All right, and this then will give us our first thing we need to look at. And that is the variable selection. What is going to be the best? And we were supposed to use CP to kind of determine that. So what we do is we look and see what is kind of the smallest one we have here. So if we go down here, we have, 70, 50, 27, and we're in the 4s, then we go 5, 6, 7, 9, 11. So really, in this area here is going to be the ideal. So let's choose the very least one, 4, 1, 4, 4, 4, and that was with the 6 coefficients. And let's also choose this one because that has the 5 coefficients. So let's do, what we're going to do is more calculations. So we're going to choose this subset first. And so this is going to give us the 5 variables with 6 coefficients. So it has everything set up here. So then we say next. Now all we have to do is variable selection. Again, we have to perform the subsets with 2 again. Click OK. Go to next. And again, we want the detailed report. And then we finish. And then this will give us our results for the 5 variable 6 coefficient model. Now we can look at this one. And we go on down. We're supposed to look at the validation set now. And so this is what we're looking at now is the error report. And so that's kind of our overall error is 23.9, class 1 is 26, 0 is 23.5. And this is going to be our confusion matrix, which is going to tell us how many are actually predicted for 1 out of 1 for cluster 1 for that. So it's going to be the right one, and it shows 107, and there's 201 for this one. All right, so now what we want to do is we need to go back down and we need to find, oops, too far, this. And now let's do our other one where we had the 4 variable and 5 coefficients. And you can see the variables. They're over here, 1, 2, 3, 4. And so those are the 4. And when we did the last one, we did 1, 2, 3, 4, 5. So those were the 5 variables we chose there. So this is what we're going to do now. And we have to do the exact same thing. And then we have to try to keep it all straight. So go ahead, next. Variable selection, form, best, 2, okay, next. And again, I want the detailed report and finish. All right, so going back to our validation set, now this is what we have, okay? All right, so probably the thing I should do is copy this. So we can put that maybe into a new file over here. And then let's go find the one for number 1. And we can copy that one. And hopefully we won't get them confused. All right, so that one was for the 6, I believe. Oh, it deletes everything, darn. Didn't even notice that when I first pasted it. So never mind here. What we'll do instead is we'll copy it this way. And shrink it down a little bit so you'll see it all on one page. All right, and then let's go find our first one. Copy that one. Back over here for the compare page. Shrink that one down too. All right. So what we have now is we've got our 2 models. Maybe I should go ahead and write down here what they are so I don't forget. So the 26 one, that was going to be the 5 variable and 6 coefficient. And this one was the 4 variable and 5 coefficient. So that way I don't forget which is which. All right, so what we can see here is this one is better on predicting the 1-1 because we have 2 more items here that are, it's supposed to be the actual class and it's predicted. So there's 2 more here that's proper. Now here we have 660 and here we have 654. So this one actually is 6 under this one, but the 1 class is really the one we're more caring about. So that looks better here. Now the other thing we can look at is it said look at the decile-wise lift. So now we have to go to the lifts, and so validation lift. Now you could use this and go from there, but I like to actually see the numbers. I just am a number person, I guess. And so probably because of the fact that it's going to delete everything because it's all tied together, we'll put that in here. And 26, I think that was with this one. And then so let's go over to validation chart 1. And so now we have this one. And so we'll put that over here, shrink that up a little bit. All right, so basically with this one, here we have, the errors. We have, 2 more predicted for class 1, 6 less for class 0. Our errors, they're pretty close, 23.5, 23.9, so that's not really too much different. Now, then the last thing is the deciles. So for decile 1, it's 0.9 lift, whereas for here, decile 1 is 3.03. So that is bigger, and it's significantly bigger because these are all pretty small numbers. Now, the second one is 2.55 versus 2.48. So it's putting more into that first one, which is better. And so everything we've seen here so far, I'm thinking with more putting into class one, basically the same values here, and then the higher decile left here, I would say this is the better regression. Okay. And so that gives us then, if we go back to our description, it says evaluate the two models based on the classification errors. So that was the lower, basically they're same. And then the decile wise lift, that was kind of the 3.0 whatever versus 2.89. And so I said the 3.0 was better. And it really never even talked about the different items here. We kind of discussed a little bit extra here. Putting it in the right class being predicted in the actual class versus predicted in the actual class. So that was a little extra that it really didn't ask for. I forgot about that. But errors equal decile higher here. So that's why this is a better description. And that's all based on our original output, which was, no, I can find that, this one. And that was just based on our CP. So we went down and we found the best ones. Well, the best ones were these three here, basically. And so we chose one where we had basically the 6 coefficients, and we had the 1, 2, 3, 4, 5 variables. We could have chosen the 1, 2, 3, 4 variables, but that doesn't seem as good. And then we also chose this one here. So we chose one out of each just to test them to see which is better. And we found that really that 5 variable, 6 coefficient one is better. Now, with that said, what we need to do is actually look at what the equation of the line is. And that's when we go to the stored. And that gives us the equation of the line. And if we remember, the first one we did was the 5 variable 6 coefficient. And so this is our equation of the line. And so how you would write it would be the negative 2.95, then minus 2.6 times the better do here, times the contract renewal, and then minus 1.05 times the data usage, plus 0.62 times the customer call service calls, plus 0.07 times the monthly charge, plus 0.06 times the roaming minutes. So, you know, I guess if you really wanted to write it out, well, let me do this. It's going to be that. Nope, it's not going to let me do that. I have to do it like this. Equals. And then we're going to have minus the 2.609 times, Phil, let me just copy that, that'd be awesome. And then we have after that minus the 1.050, and then times, then just kind of hit that. So we have this. And so on. So I think hopefully you get the idea. And so really now the key is we're supposed to kind of look at these in basis of churns, which is we look at our opening page. Churn is 1 if a customer cancels the service. Okay, and that's basically what we're doing. And so with what we were doing back here on that page, oops, LT1 stored. What we're doing is this is going to be equal to the churns. Okay? And so it's going to go up with positive numbers and down with negative numbers. So the contract renewal, that's not going to affect it as much because it's lowering it. Data usage is going to lower it. But customer service calls, the more we have customer service calls, that's going to raise the value. So that's going to affect the number of ones. And so that's going to cause them to cancel more often. Raising the monthly charge, that's also going to change it. It's going to be positive. So that's going to cause them to have more churns, which is canceling service. Roaming minutes, that's also going to increase it because it's positive. And so that's going to increase the chance to cancel the service. So the positive ones increase the possibility of a churn, which is the canceling service. The negative ones, it doesn't do that. It doesn't affect it that way. It takes it down the opposite way. It takes it lower, so it lowers the probability that they're actually going to cancel their service. Especially, right after you renew the contract, you're probably not going to cancel right away, and you're not going to base it based on data usage either. It's going to be those 3 items that you're going to cancel your service on. Now, if we wanted to think about this, the last question was talking about what is the overall error rate. Well, the overall error rate is going to be, let's see, LR output. And we want to go to the testing now. So this is going to be our overall one for the test, because that's really where it's going to be a key. And the overall error rate is 25.71%. So that's going to be the overall error rate for this one. And so that was actually what the question was for C, but I didn't copy that on the next page. And it says use the default cutoff value for your logistic regression model, which did, and what is the overall error rate for the test set. Well, that's what that value is there. So hopefully that helps you understand how to go through the different steps to get to your 2 different models and choosing the models. Sometimes it's going to be really hard to choose which model is the best, as far as when you get over here to your first output. Where did the LR output go? Sometimes these are all really, really close, and so you really can't tell. So what you'd have to do maybe is go to the bottom 2, because they're the lowest ones, and then you just choose the lowest 2 and then do the same thing we just did here. Choose the subset, do the calculation again on both of them, and then decide after that what are the best values as far as, let's see, your error percents for your report for overall, as well as your decile lift. And then those are going to be really how you determine which is the best regression model. So hopefully that helped. If you have any questions, still, please feel free to contact me. Thank you.